Okay, class, we're back. Anemia video 2. Anemia video 2. All right, when we look at this, when we look at the peripheral smear, this is what we're looking at. Now, we talked about the CBC right here. When we look at the peripheral smear, which is this, then the normal size of the red blood cells is about 6 to 9 microns. If they're too small, they're called microcytic. Too big, macrocytic. Normal size, normalcytic. Look at the color. The color has to do with how much hemoglobin you have. If it's too pale, it's hypochromic. If it's too dark, a lot of hemoglobin go hyperchromic, and normal color is normalchromic. Okay? So, when we look at, I'm going to go back here. So the way this workup is done is basically this. The person is diagnosed with anemia. Hemoglobin, hematocrit, red blood cell count, mainly hemoglobin. Then what happens is you do a reticulocyte count. Then the normal reticulocyte count, let's say, is 0.5 to 2% of red blood cells. If the reticulocyte count, let me pull it here, if the reticulocyte count is increased, see, reticulocytes is the stage right before the mature red blood cell. If the reticulocyte count is normal to increased, it would mean increased peripheral destruction, because what it would mean is that the bone marrow is releasing rookies early to try to compensate for the mature red blood cells. If the reticulocyte count is down, normal to down, that means you're not making enough reticulocytes because you have decreased production. So to decide if it's this or this, if the reticulocyte count is increased, it's generally going to be increased peripheral destruction. If it's decreased, decreased production. Okay, so that would take me to this side versus that side. This side versus that side. So we go back again then. So now, when we get to this side versus the other side, so we're going to go a step further. Okay. Hyperchromic, reduced hemoglobin content. Okay. Hyperchromic macrocytic, smaller than normal. Okay, so we're coming. Increased peripheral destruction. This side here. Too extensive destruction after the cells have been released. Generally find a high reticulocyte count because more and more immature cells are being released to try to help out. Okay. Possible causes of increased destruction. Hemolytic anemia. They can't last long enough. They may have an autoimmune, maybe trauma. That means it could be internal bleeding. You could have internal or external. External, you would think, oh, I see it. No, not if it's coming from the intestine, you may not. Okay, splenomegaly. The spleen is taking out red blood cells much too early. Okay, that's possible cause of increased destruction, like I said. Hereditary, you can read through these here. Hemoglobin, sickle cell, because the spleen would take those out early. Sickle cell anemia, right here. See, the spleen would see these abnormal shapes and take it out. Okay. So here are some reasons for that destruction. Okay. Decreased production. Something causing red blood cells not to be produced fast enough. Generally, the red blood cell count is low or low normal. The reason is that if a production is bad, reticulocytes also cannot be produced. So, see, we're back over here again. We're back over here. Increased reticulocyte count if peripheral destruction. And over here on that one there. Okay. So we come back. So here's kind of a little scheme here to look at it there. All right. Now, let's look at something. An iron deficiency anemia. See, an iron deficiency anemia would be a decreased production because you don't have the right stuff. Now, with an iron deficiency anemia, normally the cells are small and pale, a hypochromic microcytic, a hypochromic microcytic. Okay? Now, I'm going to go a step further and say this. The only time, if you look at this, we'll come back to this here. When you're looking at the finished product, okay. Now I want to let's just think about. I'm gonna come over here and make some notes here real quick. Okay. So if we look at production of something, okay, let's just think about that. You have to have a place to do it, right? You have to have workers to do it. Okay, this is just like we're making tires. You have to have incentives, like money. You have to have raw goods. Okay, let's look at just like regular manufacturing. Okay, let's come here. Where is the place that you would make red blood cells? The bone marrow. So if your shop got blown up, in this case, if there was a tumor in the bone marrow that could crowd it out, then there would be. Now, who's the workers? In this case, the workers would be the stem cells. It's the stem cells that make it. So if there was a stem cell problem, see up here, there was a stem cell problem, then you would have it. Okay. All right. Incentives would be money. But incentives here would primarily be hormones, because that's what's stimulating the whole thing. Now, in all three of these, if you had a bone marrow problem, a worker problem, stem cell, or this, the cells would still have the normal size and normal color. So if a bone marrow problem, they would just be making less of them, but you still would have normal size, normal color. The only one that really will give you an abnormal size and color are raw goods. Let's think of a baking shop, a bakery. So you own a bakery, somebody calls you and says, hey, I need 10 wedding cakes in the next 7 hours. You agree. Then you realize you don't have enough sugar. So what would you do? You don't have time to go get any, so you would still make the 7 cakes with less sugar. So in other words, the bone marrow would go ahead with a raw good problem and make the cells, but they would be slightly deficient, which then would cause a problem with the size and the color. Okay? That kind of gives you an idea. All right. So where we come next then, I'm going to kind of take this here. But where we go next then, come back. So that's where this would come in. So I'm coming back now to iron deficiency. Iron deficiency is a raw good problem. So the cells wouldn't have enough iron, and therefore the size and color, they would have a hypochromic microcytic. A hypochromic microcytic. So that's normal red blood cells. Here's a hypochromic microcytic. See, not enough red. That would be how the cells would look if it was an iron deficiency. Let's look at a B12 deficiency. B12 also is another raw good. Now, with the B12 deficiencies, the cells are big and red. The cells are big and red. Mature cells are larger than normal, macrocytic, and they're extra red. So macrocytic hyperchromic. Now the reason has to do that B12 is used as a coenzyme in the making of thymine, which is part of the DNA. So when the red blood cells in the stem cells are dividing, they can't make the new DNA, but if you go back to mitosis, you already kind of start making the cells get longer. So you start kind of working on cytokinesis a little bit. So the cells then would be big, but they can't divide because they can't make a new nucleus because they can't make enough DNA. Can't make enough DNA. Okay. So macrocytic. These, remember 6 to 9 is the usual, so these are larger. Okay. Now, here's one other thing. Okay. The vitamin B12 deficiency anemia could be due to you not getting enough vitamin B12, either in your multivitamins or your meats or whatever. But another reason, and this is called pernicious anemia. Now, the only time you can use the word pernicious anemia is if there's a vitamin B12 deficiency due to intrinsic factor. So just listen to me. I'm coming to the stomach. In the stomach, some cells called the parietal cells. In the stomach, some cells called the parietal cells produce something called intrinsic factor. When vitamin B12 gets into the diet, even if it's a multivitamin, it passes into the stomach, because you would have eaten it, it passes in the stomach, and it must complex with the intrinsic factor produced by the parietal cells to cause it to be absorbed in the small intestine. So if there's not enough intrinsic factor, even if you had enough vitamin B12, you could not absorb it. In that case, you would get an anemia, a vitamin B12 anemia, but they call it pernicious anemia. So a vitamin B12 anemia could be for many reasons. You're not taking enough in, but if it's that there's a problem with the stomach producing intrinsic factor, how could that occur? Well, you could have gastric irritation. There are many things that could irritate the stomach where you perhaps couldn't do it. Okay? Folic acid deficiency also will give the cells to be big and red. Now, polycythemia that's the exact opposite. That's where you have too many red blood cells. I really won't get into that. But the main problem with too many red blood cells is increased viscosity. And remember I said when blood gets viscous, it slows down. And when it slows down, it starts to clot. As a matter of fact, the barber pole from the barber shop has that red in his barber pole, because they used to be bloodletters. They used to do leeches years and years. You can look that up. And the job was to try to get rid of, for those that had too many red blood cells, to get rid of some of that because of the sludging effect. So that's polycythemia. So let's go back as a quick review. Before we close real quickly. All right. So where we are, we're saying that the workup, let me come here real quick. We're saying that the workup here is a history and physical examination, a complete blood count to say if you're anemic. Then you do the CBC, you do the blood smear, if the person is anemic. Now, if the person's anemic, you got this, then you go into the workup to see what it is. In the workup, you would have looked at all the parameters of the red blood cells, the size, the color. CBC gives some, but the blood smear even does it better because you're looking at it. If the person is anemic, to separate it out into the two branches, you would look at the reticulocyte count. If the reticulocyte count is increased peripheral destruction. If it's decreased production. That would then allow you right here to make that distinction. Then you would start looking down to see what you see. You would look down to see, is the spleen enlarged? Can we find bleeding? Things of this nature internally. See, one thing, if you're doing an internal hemorrhage, your bilirubin level might be up. That's something we brought up earlier, because you would have been destroying red blood cells inside. You could be hemorrhaging and not know it if it was coming from the spleen. So in other words, this kind of gives an idea. And as I alluded to, that the only time you'll have an abnormality as far as size and colors if you have a raw good like iron, vitamin B12, and so forth. So there it is, and thank you.